kind of follow along and see how that goes. All right, first thing about cumulative frequency graphs, we kind of talked about those already this year. Remember we made some cumulative histograms where we accumulated all the data. Well, that's what's happening here. I did want to point out to you that I get some of this information from college sites as well. A lot of my problems will come from college statistics classes as well. And they call them ogives. I mean, you can hear that we've got cumulative curves. They might be referred to as ogive. I don't think AP uses that particular vocabulary. Typically just see them as cumulative frequency plots. Now, first thing I want to say is look at this data we have. Below is a cumulative frequency graph representing 50 final exam scores in statistics. So my question to you is, if there are 50 final exam scores, why is there a 100 right there at the top? That's my first question to you. 50 final exam scores, then why is the total accumulated a 100? We are adding it up. Why is that not adding it up to a total of 50 exams? Haha, good job. Because this is cumulative relative frequency. A relative frequency means relative to the total. That implies relative to the total. And that means percent. So this is 100% of the 50 exams. All right, so I want to make sure that when you read these, that you focus on the labels. You have to really decide if your labels on the side are just cumulative frequency or cumulative relative frequency, or if it's just regular frequency, okay? Now, let's go ahead and tell what this point right here says. This very top point tells me, does anybody know what that tells me? What does that translate to mean? What does this point right here translate to mean? Okay, yes, you're on the right track. It is like the 50th exam has happened by that point. So 100% of the exams, good. 100% of the exams, what? Are accounted for, but what is the bottom thing down here is score. So 100% of the exams, yep, scored 105, but it's cumulative. Do you think all 100% of the exams got a 105? No, it's a 105 or less. Yes, 105 on the exam or less. Okay, that's critical that you can do that. Now let's pick another point. I want to do this point 65, and it looks like it maps over there. What percent do you think the score of 65 maps over to? I think I'm going to say like 22 or something. Okay, so let's define what this point, let's interpret the meaning of this point 65, 22. So this point means, all right, what do you think? 22% Good. The y-axis is percent, and the x-axis are the scores. So that means 22% of students, or of exams, are what? 65 or less. Very good. Now, I want to warn you, this or less is always associated with the x-axis. Do not ever tell me a percent or less. Don't tell me 22% or less. No. The or less is the accumulation of the x items. Okay, it's the accumulation of the x items. Okay, very good. Next, let's go through this and let's find our Q1, our median, and our Q3. Okay, so how could we do that? Q1 represents what percentile? The first 25%. Very good. So will you find that score at 25%. Let me see here. There's 30. Here's 25%. Okay, so track that on over. Yeah, that sounds good. I'm going to say Q1, 25% of students got about a what? 67 or less. Okay, what do you think about that? Do you follow me? Tracked this Q1 over to a score of 67. Okay, find the median, which is actually what this question A is asking. That is the 50th percentile. So find that. Let's guesstimate that value. I like it. Let's say about 77. Okay. How about Q3? Q3 is going to be what quartile? 75th. So track on over. 75th percentile. Probably. I like it. It's about 87. Now, if you're a little off on these, I know. I can follow. I can see that, you know, you're going to be within a certain amount. I know that you might be a little off. You might have chosen 86 instead of 87 or whatever. Okay, so now that we have it, I also want to think, you know, you could technically superimpose a box plot on top of this because my box would be like that. There's the start of my box plot. Okay, there's the start of the box because that's the Q1, the median, and the Q3. All right, so how about, could I determine from this box plot if we have any outliers? How could I figure out outliers? What do I have to do to figure out outliers? Find what? Well, yes, very good. Find your fences. So let's do that. So technically, I know that my IQR is how much? 20. Very good. So I want you to right now find your fences. Remember our little Q1 minus 1.5 IQRs and Q3 plus 1.5 IQRs. Okay, so our lower fence is 37 and our upper fence is 117. So let's go put those in there. There is a lower fence of 37. What do you have to say about that? There is something below that lower fence. So therefore, I can say I what? Good. I have at least one lower outlier below 37. Okay, I have at least one lower outlier below 37. Okay, good. Let's put the upper fence on there at 117. Okay, so if my upper fence is at 117, what do you have to say about outliers? No upper outliers because my maximum is 105. So I have no upper outliers. Cool. All right, so let's kind of let's finish drawing our box plot here. If you can envision, my whisker on the right-hand side is going to go out to there. Now, my whisker on the left, I know I've got some outliers. Technically, my whisker really shouldn't track to the fence. Where is my whisker supposed to go to? Good. So I need whatever the next piece of data is inside this fence, that's where I would draw my whisker to. I don't know where that is, so I'm just kind of marking that by the next. See, I use that word next because I don't want you to think that my whisker necessarily goes to the fence. And then I have this over here. So here's my next question. Look at that box plot right there. Could you guesstimate the shape of this distribution from that box plot? Anybody look at this distance here compared to this distance here? I'm thinking it's farther to the, it's stretched a little bit to the left. Do you see this? Stretched a little bit more to the left than it is to the right. So if I was to say a shape, I would probably say that it is slightly, what? Slightly skewed left. So in summary, we can do socks. Socks is when you describe the distribution. So what does the socks represent? Shape. And what's my shape? Slightly skewed left. What is the O? Outliers. And what do I have? At least one lower outlier below 37. Okay, what's the C? Center. What is the best description of center for this? Median is 77. And what's the last S? Spread. What is the descriptor of spread for my problem here? IQR is 20. So look at how much information you can get from that one picture. That's a lot. That's a lot of information about that. We can describe the whole distribution from that. Okay, now, let's go ahead. I want to, this question C is pretty much an awesome one. So let me have you just answer this one, question C, and then we're going to move on to the next problem. So look at question C and answer that.
Miss McCollum,
Yes.
if I go to the office, my mom checked me out, and she told me to go down there.
Right this minute?
Yeah.
Okay, I guess if you're checked out, you can go. Okay. So failing is 70. Okay, so I estimated a 70 right here at about that 33 percentile. So what's the answer to the question?
67.
Yes, 67. Dun, dun, dun. If you just put 33, that's no-go. You told me the percent that failed. Okay, yeah, 70 is fine. Yeah, so you could probably say this is 30 to 33%, whatever percent, that's the failures. And so if you were going to answer question C, the percent that passed is that 67 to 70% of students passed. Okay, all right, because passed is this upper part. All right, so I'm going to say 67 to 70% passed. Very good. Let's do one more of these problems. And so let's go on to this one right here. Okay, remember I told you the very most important thing is we focus on labels and we understand what this is about. So this is a cumulative frequency curve for the daily high temperature during the Aspen school or ski season. So what does the x-axis represent? I think that's a daily high temperature. So these are going to be degrees. I don't know if it's degrees Fahrenheit. They didn't tell me, so that I don't know. But anyway. What is on the left-hand side? Cumulative frequency. These go up to 180. So let me ask you this. Where is Q1? Can you find Q1 for me? How do I get Q1? It's 25%. Do you want to go to this little 25 right here and go on over here? That is a no-go. That is the 25th day. not the 25th percentile. These are the over here on the left-hand side is the number of days. So this is number of days, and of course, cumulative, not percent. So how can I find? Let's go ahead and do that. Let's find Q1, median, and Q3. How can I do that? Okay, cool. So we want to find what? First, let's find 25% of 180. And that is 45. So the 45th day is going to be, the 45th day is where you will find your answer. So that means Q1 is what temperature? So let's find that. How about 32? 32 degrees. See the temperatures down here on the bottom? Yeah, the 45th day tracks down to 32 degrees. Okay, median, what's that going to be? The 50th percentile of days, which half of 180 is going to be the what? The 90th day. So you need to track over and find the temperature at the 90th day, and that will be your median. Okay, or let's say 40. Okay. All right, where will Q3 be located? At the 75th percentile. So the 75th percent of 180 days is 135th day. Okay, so I'm going to, oh wait.
Why is, where did it be?
I'm going to say 47 degrees. Okay, so my Q1 is occurred on the 45th day, and that was 32%. Okay, so I want you to find the outlier fences right now for me. Okay, so find the fences. So I found a fence at 9.5 degrees and 69.5 degrees. So do I have any lower outliers? No lower. Do I have any upper outliers? Yes. How many? At least one. Good. At least one upper outlier. Okay, I want you to sketch the box plot on top of this graph. Sketch the box plot on top of this graph. So let's describe the distribution with our socks. What would you say the shape is? I'm going to go with slightly what? Slightly skewed right. Doesn't this look longer on this side over here to the right? That's slightly skewed right. Stretched to the right is skewed to the right. We already determined that there's at least one upper outlier above. Do you see how specific I am? 69.5 degrees. Okay, what comes next? Center. And what is my center? Median of 40 degrees. Okay, and what's the last thing to describe the distribution? Spread. What's my spread? IQR is a 15-degree span. Okay, now, I do want you to do one of the problems on this page. I want you to do letter D on this page. So go down here, and there's two little questions that D asks you. Let's see if you can do that on your own. So go for it. We're gonna act as though there's 180 days accounted for in this season, not just 179. We're rounding up to 180. So do that one now. Letter D. Okay, so how many days did you get that exceed 46 degrees?
47.
Okay, so if you, I went from 132 up to 180. And so whatever that subtraction is.
46.
Okay, so you probably 46 to 48, whatever it was that you decided. So I did 180 minus the 132, and I got 48 days. Okay. Now, let's talk about the ones that are at or above 60 degrees. So if I go up here to the top, 60 degrees, that's going to be, I went from day 167 to 180 days. So that's about how many days? Okay, about 13, okay. But that is not the answer to this question. Why?
Because of percentages.
Perfect. Good. That is 13 days, but it asked for what percentage of the season. So how do I get the answer? 13 out of the total 180 days, which would be whatever that is. Probably like 7.5% or something along those lines. What is it? 7.2%? Okay. So somewhere along those lines. So it's 7.2% of the season that had temperatures above 60 degrees. Very good. Now, the last thing I want to do, so we're done kind of like going through problems. The last thing I want to talk to you about is on page 47. So, and tell you what your homework is as well. So your homework is pages 43 to 47, of which we've already done part of 45, okay? 45 to 47, and they are a lot of these just kind of basic questions about this thing. By the way, what estimate the shape of this one right here? What would you guess? Think of it like this. You got this, you got this. So it's probably going to be more what? Skewed right. Okay, good. All right, keep going. Let's go on to page 47. That's the one I want to talk to you about. So head on up to page 47. Here we go. Oh, sorry, 46. That's the one I meant. 46. 46 has got 3 distributions. Man, I love this problem. It's got 3 distributions, and so what I want you to do right now is I want you to draw, kind of just sketch the box plot on each one of these real quick. What time do we have? How are we doing on time? We only have 1 minute? Oh, we're done? Oh, we have 5 minutes. Excellent. Okay, this is perfect. So I want you to sketch a box plot on each one of these distributions, A, B, and C. So I'm going to kind of highlight where the Q3 and the median and Q1 are, so I can kind of sketch my box plots. Okay, now you can't have whiskers on there yet because what do I have to do before I can draw my whiskers? You have to do your fences to see if you have any outliers. Very good. But if you were to guess, what shape would you guess this distribution A is? Skewed right. What shape would you guess B is? Symmetric. And what shape would you guess C is? Skewed left. Very good. So, and then you can figure out what if there are outliers, and you could figure out their centers by what would you give me for their centers? What value would you give me for their centers? The medians. And then what about their spreads? Those would all be the what? Okay, so now let me tell you the instructions. Compare the distributions. Compare means you need to use comparative language. What do you do when you use comparative language? What are you trying to do with things?
Make connections.
Make connections. Compare them to each other like contrasting and similarities. So you should use language like more than, less than, higher than. So you should compare one of the items to the others. Don't just tell me socks for A. Don't just give me the socks for A, the socks for B, and the socks for C. I need a comparison of their socks. Compare their socks. So, for example, let's do just one quick thing. What is the median for distribution A? The median here is like about 18. What's the median for distribution B? Looks like it's about 40. And what's the median for distribution C? Okay, about 60. So what kind of sentence could you say that's comparative language for their centers? What could I say? The center of distribution A, which is a median of 18, is what? Less than the median of B's, which is 40, which is the less than the median. Yes, very good. Using comparative language. Very good. Okay, so that's the last thing that I wanted to explain to make sure you did a good, solid job on your homework, pages 43 to 47. Oh, did I? Hold on. Homework is pages 43 to 47. Is that good? Okay, 43 to 47.